Good morning, everyone. In the last session, we discussed about the one of the important concept called generics here. So today we'll discuss about the another important concept called lambda here. Okay. So as we discuss here, generic concepts are introduced from the 1.5 onwards, and here the another important concept, the lambda expression, so which is introduced in our 1.8 here. Okay. So these are all the two version changes. So if you observe another important information here, if you observe another important information, basically from the 1.0 we have, like, we are trying to change all the functionality here. Whatever the functionality we are having, we are trying to change all the functionality into our Java language here. So inside that, the first one is the biggest changes, something like 1.5, and another one is 1.8 here. So these are all the some biggest changes we need to discuss here. Okay. So in the last session we discussed about the what is the biggest change here. Getting the point. Now, what we need to understand here. So another important concept we need to understand, something like 1.8. So that is called lambda expression. Okay. So that is called lambda expression. Getting the point. This is one of the important example we are going to discuss in our today's session. So basically, how this particular lambda expression is going to return. So what we need to understand here, when they added this particular lambda expression here to for the primary two reasons here. So what are the two reasons we are having? First, basically they added the new syntax elements here. Getting the point? They added the new syntax element to the increase the expressive power of the language here. Whenever they added the new the whatever the new syntax, basically lambda is a new syntax here. We as of now we did not discuss about the this particular example here. Okay. So in the 1.8 only the new syntax is introduced, that we'll call it as the lambda expression here. So because of this increase the power of this particular our Java language, they added the new syntax here. Okay. And another one is, so it is going to getting the lambda expression is going to capable the, so incorporate the API libraries. So it is going to provide the different API libraries here. Getting the point. This is another important example we need to understand here, how this particular another important example we need to understand how this particular using this particular lambda expression, how we can implement the new API related informations here. Okay. So this is very important example we need to understand here. Getting the point. This is the one of the important example we are discussing. The first one, so they added the new syntax here, and another one using this particular new syntax here, we can implement the getting the point. We can implement the API related example. So we'll see how we can write this particular API related examples. Yes. Okay. So let me write the simple example. How this particular lambda is going to provide. This is how this particular lambda is going to provide. Okay. So this is I want to provide the simple example. Here something like this section we'll call it as a lambda here. Okay. So this one which is going to work as our lambda expressions here. Now we'll see how this particular arrow it will do, like what exactly the left side values we can provide, and what about the right side value, how it is going to work. We'll try to understand this particular example. Basically, whenever we are trying to work with this particular lambda expressions here, first we need to understand the lambda expression. Second one, we need to understand the functional interface. Getting the point. Second one, we need to understand the functional interface. So this is one of the important concept we need to understand here. Okay. So this is the one of the important concept we need to understand. And basically, whatever the lambda expression we are going to write here, so this is the particular lambda expression internally, it is unnamed here. Basically, whatever the any lambda you are going to write, the lambda cannot have a name here. Okay. So simply the lambda cannot have a name, an anonymous method we can call here. So anonymous method is nothing but, so it cannot contain the name of the method here. Getting the bus. So this is one of the important example we need to understand. Something like anonymous is nothing but unnamed method here. Okay. And here, what I'm trying to provide the information. So first one is a lambda expression. Second one is a functional interface. Because if I want to work any lambda expression, it depends on the expressions as well as functional interface here. So functional interface we discussed in the previous example, how the functional interface is going to work. Basically, functional interface contain only one and only one abstract method. Getting the point? One and only one abstract method. So those particular interfaces will call it as a functional interfaces. This is one of the important example we need to understand here. So if I want to write any lambda, what are the basic syntax we need to follow? We need to follow the lambda expression, and another one is we need to follow the functional interface. So the functional interface only it's going to use the inside this particular lambda. If you are writing the normal interface, so it's cannot used by this particular lambda interface here. Okay, this is very important we need to understand here. Now what I will do, getting the point. So as I explained here, what happens internally, so this particular the lambda operator, or we can call it as a new operator. So what is one we are going to call as a new operator? Something like the arrow. Whatever the arrow we are having, the arrow we'll call it as a lambda operator. Okay, so this particular operator, it is divides the lambda expressions into two parts. So this particular lambda, it is going to divide the expression into two parts here. The left side specific any parameters, it is required here. Okay, whatever the left side parameters we are going to provide, and it is required. So if we are not providing anything, so we can identify the method will not take in parameters. Okay, the method will not take any parameters here. And the right side, we can call it as a lambda body. Getting the point. So this is the import section. This we can call it as a lambda parameters. Okay, and lambda body here. This is one of the important example we are discussing. So if the method is not taking any parameter, we'll try to write empty like this, and the operation we are going to perform like this. So this is the lambda operator. Getting the point. This is the lambda operator. And so what we need to understand here. So it contains the two types of bodies. First body, getting the point. Body basically, if I want to write multiple codes, we can define the braces like this. And if you are interested to define only single line, no need to write this particular curly braces here. Getting the point. This is we'll call it as a two types of bodies here. This particular two types of bodies where we can define inside this particular lambda here. For example, now what I will do whenever we clear this. So what I will do, this is the simple lambda I'm going to call here. Okay, this is not going to take anything, and it will return something like 1, 2, 3. Okay, 1, 2, 3, 4, 5. Now what we need to understand here, the method basically how it will define here. How this particular method will define internally. So this is the double method we are having. Getting the point. So this is name of the method. So just for understanding, I'm writing it. This method is not going to take any parameters here. So it is a empty parameters, and internally we'll try to write a return statement here. Return statement, and what is the value we are going to return? 123.45. Okay. So this is important here. Now how we are writing this entire method information? This particular method information, how I define this particular method, this is using this particular lambda expression. Lambda expression, the method, this is the parameter section. So just now we discussed about lambda parameters, and this is lambda body. Okay. Now what we need to understand here, if we are taking any parameter the particular method, we can write this. Otherwise we can move on to the lambda body, and the lambda body, Now I'm returning 123.45. So this is the internal, the method implementation like this. But if you're not interested to write this particular method, what we can do? So directly you can write this particular lambda like this, and lambda itself internally it will create the method and it will do the operations here. So explicitly we don't want to create this particular methods here. But here, so I'm explaining here how this particular method is going to be look like here. The below code, this is the method internally the lambda is going to create here. Okay, and another one. So what we can write here, observe carefully. So this is another lambda I'm writing here. Okay, and this lambda also is not going to take any parameters here. And if it's not taking, we already discussed about this particular math dot random values. Math dot random value, and it is trying to multiply with this particular 100 here. So observe carefully. Again, this is right side we'll call it as a lambda body, and the left side we'll call it as a lambda parameters. So how it is going how we are going to implement the parameters and body with help of this particular lambda operator here. The arrow operator will call it as the lambda operator here. Okay, now what is doing here? It is trying to find the random value. With the random value, it is trying to multiply with this particular 100, and whatever the result we are going to get, the result here it will try to return here. Okay, now what we need to understand here? So another important here. Now you can see this method is expecting one parameter. Now here I'm trying to multiply this. Okay, I'm trying to use the divide operator, like the module operator. Getting the point. This section we already discussed in the earlier example here, but here now you can see this is I'm checking here. So just is getting the point. So we are passing one parameter. Getting the point. We are passing one lambda parameter, and here I'm trying to do what I'm doing here. I'm trying to divide. Getting the point with the help of this particular module operators here. If the remainder, if we get 0, we are going to return as a true. Getting the point. Here we are trying to return the Boolean value. This is important here. So this is nothing but small expression we define here. The expression is satisfied or not, how we can identify with help of this particular Boolean value here. So we are trying to use the double equals to operator to check the right side value with the left side value. Okay, so this is the lambda we are going to use here. Now we need to discuss about the functional interface, because each and every lambda, it's internally it is work on the functional interface. So what exactly the function will contain here? The functional method, functional interface can contain only one and only one abstract method here. Okay, this is important, we need to understand here. So how we can write this? Getting the point. How we can write this information? So something like simple interface. Okay, and interface after interface. Now what I'm doing here? This is the my number. Okay, my number I'm having. So I'm trying to write the method. It will return the double value, and so the name of the method called get value. So this is the method I'm declaring here. This we'll call it as a functional interface here. Functional interface can contain only one and only one abstract method here. Okay, and here, so the particular method implicitly public and abstract here. We already discussed this particular method whenever we are discussing about the interface. If I'm not adding any the access modifiers here, by default it will be public and abstract here. Okay, and so like using this particular abstract method, we can define the behavior of this particular default method. Getting the point. Now basically whatever the default method we are going to write, so the default method cannot contain the abstract behavior, because it's contain the concrete behavior, like we are going to write the method body of the method inside this particular interface here. So observe carefully how we can write the simple example on this particular lambda so that we can easily understand here. Okay, so we can easily understand this particular example. Let me create one simple example here. First, what I will do, I will create one package first. So this particular package can contain all the lambda related example. Okay, so here I created lambda, and here I'm going to create a first one interface we need to create. What is the interface I'm trying to write here? My number. Okay, so just now we discussed about the my number interface here, and the my number internally it is trying to return the double get value. Okay, so this is the one of the functional interface here, and now what I'm doing here, I'm trying to write the implementation class. Observe here, lambda demo, and inside this particular lambda demo, now what we need to understand here, we need to write the inside this particular like main method, I'm trying to write the particular lambda here. So now observe carefully how I am writing it. So here I'm trying to write the get in the pen. So the lambda is not going to take any parameter, and it is trying to return the something like some value. Now observe carefully what happening internally. So this is getting an error because so compiler cannot understand what exactly it we needs to do. And whenever I'm trying to assign this, with help of this particular my number num is equals to. So now observe carefully, the error is resolved here. Getting the win. Now the error is resolved here. Now what you understand here? Basically, whenever we assign the variable, compiler understand here. So this is expecting the functional interface type, and internally it will look up the get value method, and it will try to return this particular value here. Getting the point. And whenever getting the point here, whenever I'm trying to print this, num dot get value. Now, if I'm going to print this, now you can see 123.45. But how it is getting the bed? How it is getting here? This is one of the important example we need to understand here, because lambda expression internally it is implementing this particular method called get value method, because here we are not implemented the particular method. Now observe carefully. Just we declare this particular method. Okay, here we don't have any implementation. Now observe carefully. Here we don't have any implementation here. So just we are writing the expression here, lambda expression, and the lambda expression is trying to return this particular value. So it is now matching with this particular double. For example, if I change this to strings here, now you can see you are getting an error. Now you are getting an error here. Why we are getting an error? Because whatever this particular number, we cannot convert into this particular string here, because it is a double number. Now what is the method is expecting? What is the method return type we made as a string? Because of this, it is not cannot convert it. Now you can see mismatch, cannot convert from double to string. Getting the point. So this is important here. So this is the way we can define the one of the important example, and I'm going to write one more example here. So whatever we discussed just now, something like math dot. So we need to import this particular math class. Mm, I'm copying this and I'm going to modify num1 is equals to math is a one class which is available in the java.lang package here. So you can do the some mathematics related example here. And this is the one of the method I'm calling something like random method. Okay, with help of this particular random method, I'm trying to multiply with 10 here. So this is fine. If I'm going to multiply it 100, it will get some big value. So only the 10 is fine. But what we need to understand here, how this particular value is now converting here. Okay, how this particular value is converting. First, we'll go to the math class. Now, again, this is the final class. We cannot extend this particular class here. All the predefined classes, getting the point. All the predefined classes, we are not going to extend to any other classes because by default they made as a final here. And now you can see, so this is the pi value. They provided something like some e value and the default constructor. Now you can see this is the private default constructor. We cannot create object of this particular private default constructor. Basically, now the private constructor it can call within this particular class. But now we are in the different package. Now if you see, this package is java.lang package. Now what is the package we created here? So com.core07 lambda. Okay, so this is the different packages. Whenever we are having this particular different packages here, what we need to understand here, the private and default to modifiers we cannot use. Getting the point. This is important we need to understand here. So some of the constant variable, basically this is we'll call it as a constant variable. Now you can see public static final double. This is the pi value and this is the I value. Now you can read this natural. So this is the logarithm they are using and this is they are using this particular pi. Same way we can use some different purposes they define this particular value. Now observe carefully. So this is the one of the sign method. Okay. Now you can see public static double the sign method. It is expecting the double per value and it will try to return the with help of this particular same the double value. Internally they're calling one more sign method. Okay. So cos method. Getting the one. So tan method. So these are all the mathematics related classes that okay assign method. And here so same like cos tan something. So reduction. Okay. So degrees and like now you can see we have a what are all the expression we use in the basic mathematics cell, all the example we can use inside this. Okay. In that case only now you can see square related method. So we are using the method something like random method. It will try to give the random value. So just go to this particular class. You understand the what are all the methods we are having and how the methods are internally it is converting. Now I'm moving into the random method. So this is the random method we are calling. But observe carefully what they are doing here. So this is the another class, random number generator holder. Okay, they are calling the holder class, and with help of this particular holder class, they are calling random number generator. Okay, this is important here. So based on that, they are calling the next double. Whatever the value we are going to get, again, based on that, they are calling the next double value. Okay, so this is another important the information we need to understand how this particular the random method is calling internally. If I'm going to print see this, what we are doing is we are trying to create a random. So internally, the random class we discussed in the earlier example, random class it's going to contain the multiple methods like integer related, double related, next double, next into something we can identify this. Okay, but where we are defining this inside this particular holder class, they are trying to create a one final object. Okay, so only one time this object we are going to create, and once object is created, we are not going to modify this particular object. And same way, this is the final class. Okay, so this is a final class here. So it is nothing but it is one of the nested class here. where we are defining inside this particular math only. Inside the math only, we define the one class called random number generator. Okay, so this is important. We need to understand here. Now you can see. So if I want to find this 807 line we are right now. So you can see. So 768. Inside the 768, they created the one of the private static final class. This is not the public class here. Okay, we cannot access the outside this particular class because they created internally to create this particular variable. So we, with the help of this particular random construct holder, they are using this particular reference variable, and based on this, they are calling the one of the important method called next to double. So it is returning double value. So this is we are using inside this here. Okay, finally I will run this particular example here. Now you can see this is the another lambda expression we are using, and it is trying to return the double value. Okay, for example, if I'm going to provide here value as a 10, now you can see, so we are getting an error. Otherwise we can use a n value. So with this we discuss about the n value. Now we are getting an error here. So what is the error is indicating here? Now you can read this: lambda expression signature does not match the signature of the functional interface method called get value. Getting the point? Here the signature is not matching. Like signature is not matching is nothing but we are not providing the whatever the parameter the method is expecting. We are giving some additional information here. Okay, so this is the way we can see the appropriate the lambda expression methods, how it is working internally. Okay, this is all about the simple example and the basic lambda expressions here. And only what we are understanding here, this particular get value method. This particular get value method is implemented by our lambda. Internally it will implement and it will return the value call 1 2 3 4 5, and in our second example it will try to return this math.random, and it will try to multiply with the 10 here. Okay, now we'll see one of the another important example. Okay, so this is all about the observe carefully what we need to understand here. This is the method we implemented. It is trying to return the double value. Okay, we'll define the one more example. So this particular functional interface, it will try to return the Boolean values. Okay, this is nothing but numeric test I'm defining, and this particular numeric test basically it will return the Boolean value, and we can write any method name. Okay, and it is expecting one parameter. So this is the another functional interface. Now what I'm doing here, class I'm trying to write here, and so lambda demo 2, and whenever I'm trying to define this particular lambda demo 2, what we need to understand here, we need to write the numeric test here. I'm writing the test here, and if I'm going to write like this, it will not work here. It will not work. Now you can see what I'm doing here. So I'm trying to use the same modulo operator what I discussed earlier here. Getting the point. Now if you observe, here we'll get an error, the n value. Getting the point. Here it will give an error here because the method is expecting one parameter. Okay, the parameter value we are going to store inside this particular n variable here. Now what we need to understand here, this is basically how this particular n value is going to provide the value, how the parameter value is going to injected into the data like lambda expressions here. So this is important, we need to understand here. So let's observe how we can write this particular lambda expressions here. So as I explained here, we need to write here n. Okay, now you can see the error is resolved because the method, whatever the numeric test and the test method we declare here, the test method internally it is expecting something like a one parameter. Now we define this. Well, now what we are doing is we are trying to divide the operations here. The remainder value, if it is equals to 0, it will return the true. Otherwise, it will return the false here. So now what we can do, how we can call this? So simply, you can call this. Simply, you can call this. So something like test dot the test method. Test is a reference variable of this particular interface. So using this particular variable, now I'm trying to call the test method here. Now I'm giving 10 value. Getting the point. Basically, this will return the boolean value. Now I'm trying to write inside this particular if condition, and if it is worked successfully, we'll get this particular message. And what is a method we can write? Like what is a message we can write? So 10 is even number. Okay, 10 is even number. Now observe carefully what happening internally. Whatever the 10 we provided, it is a even number. Getting the point. This is simple one. So instead of doing this particular test here, we can go for this particular is even. This is very readable, the reference variable here. And another one more condition I'm making. Getting the point. And test I'm giving, I'm trying to provide the 9 value. And here I'm trying to write the sysout here. We'll print the 9 here. If the condition will satisfy, 9 is getting the point. 9 is even number. But we'll see whether this particular condition will satisfy or not. Getting the point. If the condition will satisfy, we'll print this particular 9 also as an even number. But now what we are understanding is only the 10 is even number. So 9 is a not even number. Because of that, it is not printing the line number 10 message. Now what we can do, here we can write the logic here. 9 is not a even number. 9 is not a even number. Now what I'm doing is I'm using the or condition. So using the or not condition here, not or condition. Here I'm using the not condition. With help of this particular not condition, the boolean the lambda expression, it will return false. So now whatever the false I'm getting here, I'm converting into true here. Because of this is the important information. Because of this particular section, because of this particular not, I'm trying to converting opposite here. Okay, this is another important example on this particular Boolean test here. So this is the second lambda expression we defined here. We are trying to perform the one more information. So now you can see one more expression I am going to write. So if I want to write the one more expression, I will copy this. Here, instead of this, so here basically negative value or positive value we can print here. Okay, so here I'm trying to write the is not negative logic here. So simply what we can do, if n greater than 0, getting the bit. So greater than 0, or we can make, or we can go for the equal operator also. Because most of the cases what happens internally, whatever the n value we are having, the n value, if it is greater than to 0 or it is equals to 0. So that section what happens internally, it will try to return the true. For example, if I'm trying to give minus something like 45 or minus 60, so what happens internally, the minus related section, it is a less value to this particular 0. So in that case, it will return the false. So just we are checking the greater than condition here. Some bigger value or less value, we can check this. So yesterday, we use a comparative method to find out the minimum and maximum value. Same way, here we are going to use the greater than to find out the only positive values. Now what we can write here? Again, here also we can write What is the method we are having? Test method. I'm trying to write only one value. So I'm going to check this. Okay. I'm going to check this particular example, how it will work here. Now what you understand here, system.out.println, and here I'm going to write the, what is the value we can print here? Whatever the one is not negative here. And I'm going to write one more condition. So here, first only I'm making the not condition because I will give you the negative values here. Something like -10. And here I'm trying to write the value something like -10 is negative value. Now you can run this example. So the two example, the below what we discussed, this is the another expressions here. So this is the another lambda expression we defined here, and this is for another lambda expressions here. Okay, this is important, we need to understand. But here if you see, just we are calling the method. Okay, and whenever we are calling, basically what happens internally, we need to look up the where this particular method is implemented. Getting the point? Where this particular method is implemented, or we can call it as a where this particular method is override here, because this is the abstract method. Whatever the test method we define, it is an abstract method. Now what we can understand here, so now if you observe carefully, the test method, it is implemented inside this particular lambda expressions here. So lambda expressions take care of implementing this particular test method, and whatever the logic we are writing here, it will try to write the same logic inside this particular test method here. But explicitly we are not going to write anything. Lambda, it will take care of everything. So now if I want to run the lambda, what we need a functional interface as well. Without this particular functional interface here, can we write this? Nothing. Now you can see, if I'm going to write one more, so default method I'm writing. So default method basically so this is a default method. How we can access this particular default method? And here we can access this particular default method. For example, here is event dot default method. Okay, is event dot the default method we can access here. Now it is printing. This is the default method. Now what you understand here, we can call any number of default method. But how we are getting this particular object here? The object we are getting with help of this particular lambda expressions here. Okay, if you are not writing this particular lambda expressions here, how we are going to call the default method? So there is no scope here. There is no scope because the test method, it needs to implemented by one of the implementation class. Then only we can call this particular default methods as well. Getting the point? Anyway, what we need a reference variable basically. So the reference variable can contain this particular object information. Using that, we can call the whatever the default method we implemented. So abstract method basically it contain only one, and it's contain the multiple default methods. So for example, if I'm going to write another method, so now I'm returning this particular string here, something like a string test method, and which will take string a comma into b, string a comma into b. Whenever I'm trying to save this, now you are getting an error here. Whenever I'm trying to save this, I'm getting an error. So where I'm getting an error? In the two lambda locations, I'm getting an error. So observe carefully why we are getting this error here. So the target type is the expression is must be a functional interface. Okay, whatever the target type we are having here, it should be a functional interface. Functional interface basically it contains only one method. Functional interface can contain only one method. But right now, what we are doing is we are defining two abstract method. Whenever we are defining this particular two abstract method, so Lambda cannot implement these two methods here. It will try to implement only one method here. Getting the point? This is one of the important example we are discussing here. This is one of the important example we are discussing here. Okay. So any questions regarding this particular the Lambda demo 1 and Lambda demo 2 here?
Hi, sir. If we have empty, if we don't have any parameters, what does that empty that braces means, sir?
Here we define that. So this is only.
Yeah. So it will not, it doesn't have any parameters, so it will just treat as a normal, right, sir? So how is
Yes.
it?
So same thing like how we define the method. So inside this particular parenthesis only we are going to write the parameter information. Okay. Not only this, like we are defining for the constructors and methods. So everything we are going to use the same. So same thing that is applicable to this particular lambda. If you provide something here inside this lambda, it will try to look up the get value. So the get value is expecting any parameter or not. Now it will look up here.
Sir, if you have two arguments, can you show that one line like returning something? How we use two parameters?
So simply here only the test method, if it is expecting int comma n comma something like m, you can write the parameters here. Here we need to write the something like m parameters here. So you can write anything. Right now we don't have any other operations here. So you can modify
Yeah.
this.
Yeah, got it.
Okay. So this is the example we can write. So basically the test method, like whatever the method we are writing as a abstract method inside the functional interface. So any number of parameters we can pass, but what is the parameter we should pass into inside this particular lambda. So this parameter and the method parameter it needs to satisfy. Then only the value it's going to inject it into this particular lambda parameter, and the same parameter we are trying to use inside the lambda body. Because it is a single statement, now we could not understand much code here. We'll write the multiple codes here. Okay, so those code will give you the multiple examples here. Now you can see along with this particular n comma n, now you can define the data types also. Whatever the data type we are having, we can define the data type also into n, into m. Okay, so this is a way of writing the data type also. If you are not defining the data type internally, lambda will look up the method what exactly the data type is having. Okay, explicitly if we want to write the data type, you can write here. But only we cannot write the one parameter as the data type, another parameter with the single character. We need to write for the both, or you can ignore for the both parameter. So this is mandatory. So for example, if I'm removing this, the second parameter with the data type to definition, now it is giving me an error. Compiler will get some dilemma here. So what is the second parameter I want to provide? Because we are providing the explicit data type here. So instead of providing the explicit, if you are ignoring, compiler like the lambda will take care of converting the whatever the appropriate data type here we are having here. Okay, so if you are writing two parameters, you can make the two parameters. Otherwise, ignore the all the two parameters here. This is also one of the important the section we are discussing here. Now we'll move on to the two parameters we identified here. So if we want to do now, what you can do instead of doing this particular with the number 2, we can go for this particular m here. Okay, so we can identify this, and here Instead of providing this particular 0, what can I do? Here I can come up with the m, and I can check here. Here I can check with the m here. Anything. Once you define these parameters here, you can use inside this particular lambda body. Right now we are having only a single line statement. I'm not adding the body information. But when we are having more lines of code, we are going to add the body here. Okay. So call the test method 1, 0 minus 10, 0. Okay. So this is the way we can make the two parameters example.
Sir, in the functional interface class, it needs to be only one abstract method, sir, or and as you said, there are a number of default methods also.
So this is only I explained, right? Here I define the default method, and I come up with the one more abstract method. It is not allowing. Only one abstract method we define here.
Okay. So we can have n number more than one default methods, but only one abstract method, right?
Yes.
Okay. Got it.
Okay. We'll try to define the block of code how we can define here. So this is also another important the section we need to understand here. So let me write this particular block of code here. Now what I'm doing here, I will try to write this particular section. So the factorial logic what we implemented in the earlier, the same factorial logic I'm going to write with help of this particular our lambda here. So how I'm going to write this particular the factorial logic is important here. Okay, so let's understand the simple example here. First, what we can do, we need to define the same functional interface. So otherwise, okay, this is the numeric function I'm defining, and the numeric function internally it is going to return the int value, and I'm trying to write the name of the method as a func like function, and is going to take one parameter. Okay, it is going to take one parameter. Now what I'm doing here, this the functional interface we are going to write inside the main method. So we are going to write one class here, something like a block of code, and here main method I'm defining. So this is important because the functional method is expecting one parameter and it will try to return the one integer value. So first what I'm doing here, I'm trying to write the numeric function. So I'm trying to write as the reference variable factorial because we are trying to find out the factorial information. So here now what I'm trying to write here, into n I'm defining, and this is the array arrow parameter here. So this we are going to use inside the lambda. Now I'm defining the body. So this is the body I'm defining here. Get in the way. This is the body I'm defining, and which is expecting a return value. Get in the pen, which is expecting return value. So how we can write this particular return value? Now observe carefully here. Now what I'm doing here, first I'm trying to return the default result here. The same code whatever we used in the earlier example, the factorial logic what we used, same thing I'm trying to use here. For loop here, and int I is equals to 1. So I less than or equals to n here, because we are providing the parameter as a n here. So this is the loop I'm providing, and internally result is equals to I multiply with the result. I multiply with this particular result. Finally, I will try to return the result here. Now you can see this is the lambda we defined. So now it is contained more than one line of code here. Okay, now it is contained more than one line of code. Now what I will do with help of this particular factorial, with help of this particular factorial, I am going to call the what is the name of the function we are having, func, and I am going to provide the 3. Okay, so this is the factorial of this particular number, and I will print this because it will get the integer value. Now you can see we are getting as a 6. Getting the point? This is the factorial of this particular number, the 6 we are getting, and if I want to give the something like a 5. Okay, 120 we are getting. Now what we need to focus here, how we are defining multiple lines of code. So this is the multiple lines of code we define. For this particular multiple lines of code, we come up with a curly brace here and we close this. So inside this, we'll call it as a method body. Everything this is code is going to convert into the method, something like this particular function. Because here we are calling this particular function here. Okay. So for example, the numeric function, if I'm going to implement this, this is a numeric function IMPL. Implements here numeric function, and here now what I'm doing here, I'm trying to implement this. Okay, so let me implement this particular method. So this is the method we are having, and I will copy the same code into this, and main method so im dot function I'm calling, the same 3 I'm passing here. This out. Okay, now if I'm going to run, we are getting the 6. So whatever the 6 we expected from the lambda, same we are getting from this particular method, but explicitly we only override this particular method. Okay, this is the simple logic we implemented in the previous example also, but just for understanding, I'm explaining this, like I'm implementing this particular interface, and I'm overriding this particular function method, and I'm calling the object creation, and I'm calling the same function here. So we are getting only the same 6 value. Now what we get from this particular lambda here. Getting the point. But instead of implementing this particular method, now what we are doing here, so just we are defining the lambda here. The lambda internally, it will convert this particular code into the functional interface method here. Okay, so this will take as a parameter, and this particular code will move on to the method body here. So this is, we need to understand the one of the important example on the lambda body. Now same thing we can implement if we want to find out the string related something like a string function. If I want to find out the length, if I want to find out the some reverse related, we'll identify the reverse related example tomorrow, and so later we'll define the functional interface how we can write here like with the generic functional interfaces. Okay, using the generic function interface, how we can write the same lambda expressions here, and how we can pass some lambda related example. Okay, we'll try to continue this example on our Monday session. So tomorrow or day after tomorrow we don't have a session here. Okay, we'll continue on Monday. So try to practice what we discussed so far, the lambda related, as well as the remaining concept will continue on Monday. Okay, anyone having any questions regarding this particular what we discussed, the lambda example so far? Okay, so if not, we can continue on to Monday session.
Thank you, sir.
Yes, sir.